we now look at how we solve for the general solution in the second case when we have repeated eigenvalues for the coefficient matrix. So let's take a look at what we have over here. We have a linear system of two variables, and we have the coefficient matrix over here, and on the diagonal we have 2 and a 2 and a 0. So for this kind of matrix, we know the eigenvalues are exactly on the main diagonal. So let's try first to find the eigenvalues. We know to find eigenvalues, we actually form the a minus lambda, put minus lambda on the diagonal, and then we find the determinant. And we see the determinant is simply 2 minus lambda squared. So we only have one repeated root, so called lambda is equal to 2. After we find the eigenvalue, we try to find the corresponding eigenvector. So lambda is equal to 2, and then we solve this equation a minus lambda I. V here is a vector and is equal to 0. So let's say our V vector has two components, x1, x2. After we plug in lambda into the matrix over here, we have 2 minus 2, 0, and 2 minus 2, 0. So we have this simple system over here. It's already in the row echelon form if you want to see. And then we have x2 is equal to 0 after you multiply the first row by the column out. And there is no x1, that means x1 is free. Because x1 is free, let's choose a non-zero number. So we choose a simple 1 over here, and then x2 must be 0. So this is our eigenvector. And there's only one eigenvector, so we need to find another vector in order to have the general solution. And we call this vector W. According to our theory, this W must satisfy this equation. The same coefficient matrix multiplied by this vector W should be equal to V. And then let's say we have components for W, W1, W2, and V is the eigenvector we just found. So we have 1, 0 over here. So this is the system we're going to solve. And we multiply the equations out again. And we have W1 is equal to 1, and no, W2 is equal to 1, and W1 is free. So we now choose a non-zero vector for W again. W2 is 1, W1 is free, so we choose a simplest number possible. This is 0. And then we have now both vectors. This is the formula for the general solution after we have found both V and W. So C1 and C2 are arbitrary constants. Lambda is our repeated eigenvalue. So we put them inside, and V1, C1 times V is C1, 0, and T times V is T0, and W is the vector 0, 1. So we add them up, and that's our solution in the vector form for excuse me, for this system of differential equations. If we want to see the final solution in individual variables x of t and y of t, we can just add them up, and then we see the first component is c1 times e to the 2t plus c2t e to the 2t. That's for x of t. And for y of t is the second component, which is c2 e to the power 2t. All right, and every system of 2 by 2 is solved in this way if the eigenvalue is repeated.